Let me introduce myself. My name is Pavel Chubunov. I am from Russia, from Moscow. I am head of department in branch of the United Rocket and Space Corporation, Institute of Space Device Engineering. I would like to present Russian single event effect test approach. Here is the outline of my presentation. First of all, I will present my company. After that, I will speak about Roscosmos testing aids, about ability for single event effect testing in Russia. I will describe the test facility, including heavy ions, protons and laser sources. I will say a few words about standards and guidelines and also software. Then I will turn to future trends and finally I will conclude my talk. The branch of the United Rocket and Space Corporation, Institute of Space Device Engineering, is a test laboratory for hardness to radiation effects. Our organization is a coordinator of Roscosmos activities within further the creation and the introduction of manufacturing methods for radiation hardness control, including following directions. Firstly, its function implementations as a head company of the Russian Interagency Component Radiation Testing Center from the Roscosmos side. Second, our main direction of our activities is creation and operation covering of testing aids, database for components and system, and also space radiation exposure monitoring system. And finally, we organized a scientific conference and other different technical events. More information about our company you can find at the official websites. Let's turn to testing, to single event effect testing. For these purposes, we use testing aids, Roscosmos testing aids. Speaking about testing aids, we mean the totality of test facilities and other benches for testing, standards and guidelines, and also software. At this slide, you can see numbers of Roscosmos testing aids in the field of dose effects and single event effects. We have a quite large number of test facility for dose effects, but in my presentation I will concentrate at facility for single event effects. Our testing aids provides tests for all types of dose and single event effects, and more than 3,000 types of components were tested to CE from 2010 up to present time. Our facility is in conformity with the international standards. It was confirmed at the several international conferences. Our facility were included in 2 editions of Compendium of International Irradiation Test Facilities. And finally, our single event effect test facility were awarded in the 2014 at the International Exhibition of Inventions in Geneva, Switzerland. So here the recognition of our highest scientific and technical level of our facility. Now let's turn to admissible technique to variables of single event effect testing in Russia. Testing is carrying out with the ion accelerator. It's the main technique, the most common technique. Proton accelerators are also allowed, and laser technique with the use of laser simulator are also allowed, but only with calibration result calibration of ion or proton accelerator. For develop test plans, we use test plans are based on typical test plans, which called program and the procedure for corresponding type of facility. Here you can see a general structure of the single event effect test facilities based on ion sources. That facility is located in Dubna, in Florov Laboratory, Joint Institute of Nuclear Research, and based on cyclotron. Ions from cyclotron comes to bending magnet. Bending magnet forms the ion beam. After that, ions come to vacuum tract, and after that comes to test chamber and strike device under test. To modify parameters of beam and to control parameters, we use a special diagnostic system which located in vacuum tract and also on the test chamber. For registration of effects, we use special equipment to control biasing condition and control electrical parameters. At this table you can see the main technical features of our test facility, which based on ion sources. All of that facility can be divided into groups. First, facilities with low energy. Low is from 3 to 6 MeV per nucleon. And the second one is the facilities with high energy from 20 up to 60 MeV per nucleon, 60 for light ions. If we take a look at the table, we can compare technical features. First of all, high energy facility provides much more range in silica, so in some cases we should not fully decapsulate device under test. We can use degraders, so we can achieve much more values of LET, so this facility is more flexible, and we can, in some cases, we can irradiate devices in atmosphere. But our best facility with low energy can provide much more square of beam, much more irradiation area. So we can test many samples at one time. All of our facilities provide evaluated temperature. So here you can see some pictures of this facility. And I would like to highlight some practical aspects for heavy ion testing. First is the number of samples. For single event latch up and upset transient testing, not less than 3. When we deal with burnout and gate rupture, not less than 12. We have to provide LET from 1 to 60 or to 100. In most cases, for that purpose, we should use 4 or 5 type of ions. Requirement for range of ions in silica is more than 30 microns. So decapsulation is needed in most of cases. We use tiled irradiation only for investigation, not for qualification tests. Test norms. Test norms for fluents is not less than 10 to 7, with taking into account possible errors, or until we register 100 of effects. When we carry out burnout or gate rupture test, safety operation area estimation is needed. For single event latch up testing, test must be provided at maximum supply voltage and maximum operated temperature. For single event upsets at minimum supply voltage. In general, we must provide the worst case biasing condition. For latch up and transient testing, UV curve must be recorded. And finally, if device is sensitive for latch up, we have to do survivability test. Survivability test means that we hold the device in a latch up for 5 minutes. Here is our proton test facility, which based on synchrocyclotron accelerator in St. Petersburg Institute of Nuclear Physics in Gatchina, nearby St. Petersburg. We have a beam line with the energy 1 GeV, but also we have a special system to decreasing energy to 200. Here is our test facility for laser testing. It's based on picosecond laser with 2 different wavelengths with maximum pulse energy on chip 8,000 nanojoules. Also, we have a large number of facilities for preparing components and for identification. For identification, we use X-ray system, scanning acoustic microscopy. For decapsulation, we use different types of facility: chemical encapsulator, mechanical encapsulator, laser encapsulator, and also plasma encapsulators. A large number of standard and guidelines acts in Roscosmos. The main ones listed at the slide. Here you can see the title of that titles of that documents. First document deal with estimation requirements for CE hardness for testing. Another 3 documents deals with test methods for different types of effects for different functional classes. And the last one deals with CE rate calculation. Also, we have special software. First one, DSG, is the set of software for calculation of interaction of charged particle with materials. And the second one, ASOT, is software for processing test results. Also, we can use worldwide standards and software listed on this slide. We have now a few words about future trends, about directions for the development of our facility. First of all, it's upgrade performances of existing facilities, which allows us decrease testing costs and increase the efficiency, accuracy, reliability, and availability of our facilities. Second direction is the creation of reference ion beam and the system of metrological support. Next one is the creation of test facility with milli and micro beams for fundamental investigations. Next is the creation of technical bench for ensuring decapsulation of electronic components. And finally, we plan creation new test facility with average energy, which based on existing and construction accelerators in Joint Institute of Nuclear Research in Dubna. In conclusion, I would like to highlight several theses. Admissible methods for single event effect testing were determined on accounts of their realization at Roscosmos test facility. Single event effect testing aids were created and are currently in operation. This testing aids provides tests for all types of single event effects. More than 3,000 types of components were tested to CE. Directions for the development were defined, and in the end, I would like to invite you to joint research, the common application of Roscosmos test facility for electronic components radiation testing. So we have no restriction for foreign organizations, so you're welcome. Thank you for your attention.